Welcome to question 6 of the 2006 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on to the problem, I'd just like to point out that the use of a CAS calculator is an efficient way to help approach this question. So for question 6 we consider the function f with a domain of a to infinity with a rule f of x equals log e of x to the power of 4. And we want to consider the values of a when the inverse function will exist. So the thing we need to consider here is that for an inverse function to exist, we need the original function f to be 1-to-1. So the best way to work out how we can restrict f to be 1-to-1 is to graph it using a CAS calculator. So we want to graph it and then find some domain, some restricted domain from a to infinity where f is 1-to-1. On the CAS calculator, go into the main menu. Next, we want to type out the rule for f of x. So pressing keyboard to bring up the soft keyboard, we can go into Math 1 and then click ln to get log e. And then we want x to the power of 4 inside. And what we want to do is we want to sketch this graph. So hitting the graph icon, we can now drag that down and it will sketch log e of x to the power of 4. So from the CAS calculator, we got a graph that looks something like this for the graph of f of x. And now our job is to identify a section of that graph where it is 1-to-1, where we're ultimately heading towards infinity. So we're going to start at some value of a and go towards infinity. So looking at the right-hand side of the graph, where we're approaching infinity out here, any of these values of a, so a lower bound of anything greater than 0 in other words, give a 1-to-1 function. So looking through the options, we can restrict the graph from any a value that's greater than 0, so that means that d is correct, and as long as we go from that a value that's greater than 0 to infinity, the graph will be 1-to-1, which means the inverse will exist for that function. So option D is the correct answer for this question. From the examiner's report, we can see that 74% of students got that question correct, so it was reasonably well done in the examination.